All right, I've decided to go through question 30. It's not that this is a difficult problem, it's just that there's many parts to it and lots of work involved. And it's taking on average students about 12 to 16 minutes to finish this. So hopefully this won't be a very long video, but hopefully it will help you get you started as you go through this. I think it's 6 parts. Okay, 40 new automobiles were tested for fuel efficiency by the EPA, and they're looking at miles per gallon. So each of these pieces of data is an automobile that they tested to see, I guess, what they get, every gallon of gas that's used, how many miles they can go. Okay, so these 40 individual MPG values are displayed below. All right, first up, find the mean miles per gallon, round to the nearest tenth if necessary. Okay, so your mean, if you recall, is just an average, right? So think about this, we got 40 cars being tested, and you can see from the numbers that their gas mileage per gallon is all over the place. So they just kind of want to take a little snapshot of what's the average. So the average, you need to add up all 40 data points, data values. And then once you get that total, divide by the number of data points. So the formula actually looks like X bar, which is just notation for average, is going to be the sum, that's the Greek letter E, of all your data points divided by the number of data points. So I've gone ahead and added up all these data points on my calculator, and the total that I got was 1,026, and I'm going to divide that by 40 pieces of data here. All right, that came out to be, our average came out to be 25.65 miles per every gallon. Okay, they asked to round to the nearest tenth. So in that case, be careful. You want to come out, this is your tenths place, right? If you think about it, 10 has 1 0 in it. So you're going to come out 1 decimal place to the right. You put up a door. That 5 is going to tell that 6 to go up. So your average from these 40 pieces of data is 25.7 miles per gallon. So just be careful. Oh, one thing I wanted to say is when you get done adding up every single one of the pieces of data, make sure you hit enter before you hit divide, right? So just be careful on that. All right, the next part is they're asking us to complete a frequency distribution. So this is just a way of using tally marks to figure out how many times you see, let's just say, an automobile that has miles per gallon between 8 and 12, and then 13 to 17. So it's like organizing your data. So you're going to have to kind of go old school and use your tally marks. So I will make another column here. These are my tallies. And when I say old school, meaning like, when you start to count with tallies, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So we're going to use our tally marks here. Now, I'm not going to waste your time on this video watching me pluck through every single one of these, but you would start off with like 37. Well, 37 belongs right here, so I'm going to put a tally mark there. And then I would go to 25. Well, 25 belongs in here, so I would put a tally mark. So what I ended up getting was one tally here. So there was only one car that had pretty terrible gas mileage between 8 and 12 miles per gallon. And then, let's see here, I think I got 3. In here. And then 8 cars fell in here. 15. Cars were in there. Now we're getting cars that have really good gas mileage. So we're 28 to 32 miles per gallon, there was 7 here, and 1, 2, 3, 4, and 6 here. So I want to make sure that you add these up. You're going to do the Greek letter E there. This should be 40. Otherwise, you've missed something, okay? Or you've counted something twice. So you're just going to kind of pluck through, right, and cross them off as you go and put the tally mark into the proper places and then add those up. And that's your frequencies. Okay, so hopefully it's annoying to do, but it's doable. Okay, so here's 40 new automobiles were tested for fuel efficiency. The individual miles per gallon, again, displayed below. Okay, use the frequency distribution to approximate the average. All right, so they don't actually want us to find the average. We already did that, right? That was back here. We know that the average gas mileage from these 40 cars that were tested is close to 25.7. So I'm not quite sure why they want us to approximate the mean, but I'll show you how to do that. You can use your frequency distribution from above to help us approximate mean. If you already know the mean, this seems kind of redundant to me, but there must be a method to this madness. So we'll round to the nearest tenth. So what we're going to do is we're going to take these classes with the frequencies, and I'm just going to kind of rewrite them down here. So 8 to 12, we had 1 car. 13 to 17, we had 3. 18 to 22, we had 8 cars. 23 to 27, we had 15 cars. 28 to 32, we had 7. And 33 to 37, we had 6 cars. Okay, so what we're going to do is we're going to go to each one of these classes and we're going to find the midpoint, right? So what is the number that's in the middle between 8 and 12? A couple ways to think about this. You could add 8 and 12, which would be 20, and divide by 2, and that would give us a midpoint of 10. So that might be the easiest way to do it. And then I'll kind of show you kind of a cheater way as we go. If you add 13 and 17, right, you're going to get 30. If you cut that in half, that's 15. So you're going to see kind of a pattern here. So you could keep doing this, 18 plus 22, and get 40, and then divide in half and get 20. So you can kind of see a pattern. It's going up by 5s. The pattern also goes up by 5s because of the class width. So in a previous video, we looked at a class width on a histogram. So the class width we were looking at lower level minus lower level. So 18 minus 13 is 5. 13 minus 8 is 5. So we know these are going to go up by 5. So this is 25 would be your midpoint. 30 and 35 would be your midpoints. Okay, so step 1, find your midpoints. And then step 2, you're going to multiply your midpoints by your frequencies. So 10 times 1 is 10. Take your midpoint times your frequency, and I'll write that out so you'll have that. 45. So 20 times 8. What's that? 160. 25, 15 times. 375. 30 times 7. 210. And 35 6 times. That's going to also be 210. Okay. So it does seem like a long process to figure out, to approximate the mean, even when we know the mean. But we're going to do it, right? We're going to give it the old college try. So to just start back, we found the midpoint of each one of these intervals. We took each midpoint and multiplied it by the frequencies, and now you're going to add this up. So when you're just taking those midpoints, right, we're just taking kind of like our best guess at the center. This is why this is an approximation, because it's not exact. Okay, so you're going to take and add up all of those and then divide it by 40. So when we do that, we're going to get 1010 divided by 40, which is approximately 25.25. Now keep in mind, right, you don't want to get Alex to give you a big error. So you want to make sure you round properly to the nearest tenth. So tenths is right here. Put up a door. That 5 talks to the 2 and tells that 2 to go up to 25.3 miles per gallon, which is pretty close to the actual mean. Remember, the actual mean, remember, this is just an approximation. The actual mean was 25.7, so we're really close. 25.7, right? So we're super close. So we're within 4/10 of each other. Okay, so that's how you approximate a mean from your frequency distribution. All right, this next piece wants you to take each of these individual values and concoct finding the mode, the mid-range, and the median. All right, this is probably going to be the most time consuming for you. Unless you have a fancy calculator, that'll do it for you. I'm just assuming we don't have fancy calculators, so I'm just doing this old school. Okay, so median, let's find the median first. So the median is going to be your middle number. Now the only way to find your middle number is to sort your numbers from least to greatest. So least to greatest. So to try to save time on this video, I went ahead and pre-sorted this. And it was a pain, I'm not going to lie. But you want to go through each one of these numbers and put them in order. Okay, so the median is the middle number. So old school, I would probably, once I have them sorted, right, from 10 to 37, I would start by crossing them off, right? So like, it's not you, it's not you. We're looking for the middle, right? Not you, not you. I'm just going to keep circling these until I can find my middle number. So I like to say in my mind, it's not you, it's not you, it's not you, it's not you. All right, so it's not you, not you, not you. And you could cross these off. I'm not crossing them off in case I need these numbers again. So I'm just circling, not you, not you, not you, not you, not you, not you, not you. I think you probably get the get the point here, right? So we're going to keep doing this, ching, ching, until we, we get to 2 numbers, right? Now they happen to be the same number. So our median happens to be 25, right? Because you have 40 numbers, it's an even number, you're going to usually have a tie between these. Now, if we had to break the tie, if these were different numbers, let's say that was like a 27 and a 28, right? You would find what's in the middle. So you would add the 2 numbers together and divide by 2 to find that middle. But with 25 and 25, they're the same number, so we don't have to do any sort of breaking of any ties. So that's your median. Okay, your mode or modes are numbers that show up more often than others. Let's see here if I can talk and write at the same time. Apparently not. So numbers that show up more often. So that's why I think about mode, MO. So more often than other numbers. Okay. So when you are sorting your data, and if you do it by hand, you will have a real good idea of what number shows up more often than other numbers. So as I was sorting these, I had 1, 2, 3, 4, 5, 6 20s. I also had 1, 2, 3, 4, 5, 6 25s. So this is bimodal. I have 2 modes. So I had 20 and 25 were 2 numbers that showed up more often than any other number. Now, a data set can have no mode, meaning there's no number that shows up more often than any other numbers. It could be multimodal, meaning there's more than 2. There could just be 1 number that showed up more often than others. But in this case, I had 2 numbers that showed up more often than others. And so I'm going to list those as 20 and 25. Okay, mid-range. Mid-range is easy. We're going to add the smallest number to the largest number and divide by 2. Dos. Okay, let me get rid of this so I have a little bit of room here. So that's gonna be how we find our mid-range. And because we spent the time sorting our numbers, we absolutely know what's the largest and what's the smallest number, and we can easily add those together and cut them in half to find our mid-range. Okay, so smallest number was 10, largest number was 37. Remember, these are miles per gallon. You probably don't want to buy a car that's only getting 10 miles per gallon, but maybe one that's getting closer to 37 would be a good purchase. Okay, so 37 and 10 is 47 cut in half, and that is approximately 23 and a half. Okay, that is miles per gallon, and this is our mid-range. Right? So that's how you find that. Okay, if you can believe it, there's still more questions, but hopefully these aren't too difficult. Okay, so which measure of central tendency would a government official choose if they want to show, if she wanted to make the case that gas mileage was getting better for new vehicles? All right, so government officials want us in the public to think that cars are getting better miles per gallon. And so newer vehicles, that's what the push is, for them to have better gas mileage. So it looks like we have like a drop-down menu. So she would want to pick and we have to choose between largest or smallest measure of average to give the appearance that gas mileage was getting worse or was improving. She would probably go with the approximate mean, mid-range, actual mean, median, or mode of blank miles per gallon. Okay, so because she wants to show that the cars are getting better and better at getting the most bang for your buck, right? The most miles out of every gallon you put in the car, she's going to probably want to pick the largest measure of average to give the appearance that gas mileage is improving, right? It's just what she want to show the public that. So which number would she probably want to go with? So she's going to want to go with the highest, right? So remember, the approximate mean was something like, let's go back and look, 25.3. The mid-range, we just calculated that as 23.5. The actual mean was 25.7. The median, let's go back to that. I might have erased the median. Oh, that was 25. Yep. And the modes were either 20 or 25. So you want to get the largest one. So the largest one for us is 25.7, which was the actual average. All right, so we want to go with the actual mean of 25.7 miles per gallon. Okay, which measure of central tendency would an environmental lobbyist choose to show if he wanted to make the case that gas mileage was still not very good for newer vehicles? Okay, so this environmental lobbyist is coming at it from a different angle, right? So the government official wants us to choose new cars, and they want to convince us that they're getting really good gas mileage. So she wants to give us the best of the best, right? A lobbyist has got a different angle. They're saying these cars are still not producing the best mileage per gallon. So that person, he or she, might want to pick the smallest measure of average in order to give an appearance that the gas mileage, it's not improving. They don't want to show that. Maybe they can't really prove it's getting worse, but maybe still had room to improve, right? Car manufacturers could do better. So what are they going to want to pick, right? So they're going to want to pick the smallest. So if we go back, the smallest is our mode of 25. Or excuse me, 20. 25 is also part of the mode, but 20 is smaller. So they're probably going to want to pick the mode of 20 miles per gallon. All right, thanks for sticking with me. I'll see you in the next one.